I always never prepare the date when I start recording these things. It's the 26th of March 2015, and we are on the second part of section 6.6, which is analyzing quadratic graphs. And we're going to learn how to use completing the square to make an ax squared plus bx plus c parabola and put it in the vertex form. And we're going to start on example 2, which is at the top of page, whatever I just said a second ago. 324. Page 324. So we have to get through examples 2, 3, and 4 today. And currently there's no Josiah and no Jessica, so we're recording for their benefit. Okay. So at the top of the page it says write quadratic functions in vertex form. And alrighty, here we go. Given a function of the form ax squared plus bx plus c, which should be super familiar to all of you by now, you can complete the square to write the function in vertex form, which is a open paren x minus h squared plus k, okay? And where h and k are the vertex coordinates. Alright, let's check out what they want us to see. Right, y equals x squared plus bx plus c in vertex form. So when there's no a value, right? No coefficient in front of the quadratic term. So they give us y equals x squared plus 8x minus 5, and they want us to write it in vertex form, and then analyze the function using that information. Okay, we know how to do that based on example 1 and all the homework practice we've been doing.
Mm-hmm.
All right, so we have y equals x squared plus 8x minus 5. Notice that x squared plus 8x minus 5 is not a perfect square, right? What multiplies to be negative 5 and adds up to 8? Definitely not some common thing, right?
Mm-mm.
But we can separate this quadratic into, and they skip this step, which always frustrates me. You can separate your x squared and your x term in its own set of parentheses. Okay? So to make that more clear, you can write it as y equals open paren x squared plus 8x close paren minus 5. That is fine. Okay? And that way you can use the x squared plus 8x inside parentheses to complete the square, and the negative 5 is just hanging out. Okay? So if we just pay attention to x squared plus 8x, let's complete the square. What's half of b?
4.
4. Square it?
16.
16. Okay? So we're going to add it to the thing inside parentheses. Okay? So we have y equals, and that's the second line of your example. Y equals open paren x squared plus 8x plus 16 close paren minus your 5, and then they minus the 16. Why do you think they subtracted the 16 at the end? Anybody have a guess? Well, because if you just added 16, you would change the equation, right?
Mm-hmm.
So that's why they subtract 16 at the end. The plus 16 and the minus 16 technically cancel each other out, right?
Mm-hmm.
That's why.
Because you need the minus k.
Well, no, it's not because you need the minus k. It's because if you add a positive 16 and just left it alone, you would be changing the equation itself. So if you add the 16 in parentheses and subtract it outside, essentially you've just added 0 to the entire equation. Does that make sense?
Yeah.
Because you don't want to add 16, it would change the whole thing. So if you add 16 on the inside of the parens and subtract it on the outside, hey, looky there, you didn't actually change the face of the equation because you added plus minus 16, which is 0.
Should you do that all the time?
All the time, right? Because if you manipulate the equation, whatever you do to one side, you got to do to the other. Or in this case, whatever you do inside of the paren to complete the square, you must also do to the outside the opposite, so that it cancels itself out. Otherwise, you're changing the equation, and you don't want to do that, or you get the wrong answer. But now we can use this info and put it in our form. So again, in parentheses, we have x squared plus 8x plus 16. And then next to it, we have a minus 5 and a minus 16. So we can combine like terms and factor, right? Because x squared plus 8x plus 16 factors into the quantity x plus 4 squared, right? By the whole deal of completing the square. Okay? So we have y equals open paren x plus 4 squared, and then negative 5 minus 16 is negative 21. Hey, looky there. We have it in vertex form, don't we? Y equals x plus 4 squared minus 21. So what's h?
Negative.
Right, negative 4. Or in Stormy's case, it's 4, and she likes to say, oh, that means the vertex is negative 4. Either way is fine.
Yeah.
And what's k?
Negative.
Yeah, k is negative 21.
Yeah.
That's right. So that tells us what about our parabola? Where's our vertex?
Negative 4.
And that's the x coordinate. What's the y coordinate?
4. Negative 21.
Right. And the axis of symmetry is that x equals
Negative 4. No.
That's right. You got it. It's always the axis of symmetry is always the x coordinate of the vertex. Rock on. Okay. And last but not least, you can name A is 1, right? Can't forget about little a, even though it's not there. So that means your vertex is 4 units left and 21 units down, because it's a minus 21, right? Done. And then you make your axis of symmetry, and you can plot your little point. They just have you check it here. They say check your vertex. It's x equals negative b over 2a. Okay. I'm going to go look. Negative b is negative 8 over 2 times 1. Hey, look, it's negative 4. Works! Hooray! Right? And then negative 4 squared is 16 plus minus 32 minus 5. Okay. We don't have an equal sign, so we don't do that. All right. So, again, you've got to use completing the square to get something in parentheses squared. And your k on the outside. So if you add 16 inside the parens, make sure you subtract 16 outside so it cancels itself out and you don't actually change the face of the equation. Okay? Have any questions?
Not yet.
All right. Well, then let's go past the little check and the little paragraph that says when writing. That's right, smack dab in the middle of the page. When writing a quadratic function in which the coefficient of the quadratic term is not 1 in vertex form, the first step is to factor out the coefficient from the quadratic and linear terms. Kind of like we did with completing the square, just the opposite. Then you can complete the square, excuse me, and write it in vertex form. So, you know, there's always hints. If the paragraph above the example is about factoring out an A term, then the example is probably going to be about factoring the A term, right? Excuse me, cough is like hanging on for dear life. Example 3. Write y equals ax squared plus bx plus c in vertex form when a does not equal 1. So for this one, they give us the equation y equals negative 3x squared plus 6x minus 1 in vertex form, and then you've got to analyze, and they want us to graph it this time. So what's A?
Negative 3.
What's B?
6.
And C?
Negative 1.
All right, nice. So the first thing you do, and again they skip the step. If I were you, I would start out by just writing it the quadratic term and the linear term in parentheses, because they skipped it and they just decided to factor, right? So you would write y equals open paren negative 3x squared plus 6x close minus 1. Just so you get in the habit of knowing that, hey, it's okay to separate them. anybody know what property allows us to do that?
Distributive.
Nope. Associative, says Miss Chris, and she is right. Remember, in associative, we don't have to change the order, but we can put parentheses wherever the heck we want, right? The distributive, you would be right, Stormy, when we factor out that -3. That's true. It would be the distributive property. So when you have the -3x squared plus 6x in parent, you rightly said we can factor out a -3. So when we do that, I'm looking at the third line here. Y equals -3, open paren, x squared minus 2x, close, minus the 1. Because we're only factoring it out of the stuff in parens. That's why it doesn't say minus 1/3, in case you were wondering. Well, it would say plus 1/3 if you factor it out -3. But again, we put it in parentheses, and that's how we're able to factor it out. Now we can commence completing the square. Okay? So, what is half of b?
Two.
Well, b is -2, right?
So, yeah.
Or, sorry, it is 2, but b was 6. So, they use so let me clarify this here. You use the b that is now in parentheses with your x squared. Okay?
Oh.
You can just use the work that you're already on. So in parentheses we have -3 open, x squared minus 2x, close, minus 1. So you use the new b, which is -2. Okay? So half of b is then -1, right?
Yeah.
Square it. 1.
1.
Right? So now, the next line, -3 open, x, they forgot a squared. Do you see that, Miss Chris?
Yeah, I was
Look at
just
that.
about to say
They
that.
forgot a squared. It says x minus 2x in the book, plus 1. They mean x squared, otherwise you can combine like terms and it wouldn't be quadratic anymore. Okay. So ignore the typo there.
One says it.
The Braille says it?
Yeah.
That's weird. Well, and
That's
this is
about
print
right.
though, right? There's a typo in print. It should say, print users, -3 open x squared minus 2x plus 1. Okay? Close paren. There's your -1 you had hanging out. And remember, whatever we multiply, whatever we add or subtract in parentheses, our C term, we also have to do to the end of the equation. However, remember there's a -3 outside of that paren. Okay? So we have to put a -3 in front of our new C term as well. Otherwise, we're not actually canceling it out, right?
Mm-hmm.
Really important, okay? It's not just a subtract 1 from both sides kind of thing now, right? We also have to multiply it by -3 because the other parenthesis, that factor of -3 is outside of parentheses. That's why it says -1 minus open paren -3 times 1. You got to be really careful. If there's a factor outside of parentheses, you also have to put that factor out in front of your C term when you attach it to the end of the parentheses. Okay? But now we can do like terms and the completing the square factory step. Right? We keep that -3 out front. X minus 2x plus 1 factors into x minus 1 squared. And -1 minus -3 times 1 is -1 plus 3, which is 2. That is how they got -3 open paren x minus 1 squared plus 2. Yep. Huh? No. We're on example 3. Alright, so now we have A, and we have H, and we have K. Finally, right?
Mm.
So, what's H?
-1.
That's right. What's K?
2.
2. So where's our vertex? I know. She does it differently.
-1, 2.
Uh-oh. Nope, because remember, -1 means you go right 1. Okay?
Oh, so 1, 2.
Right, your vertex is 1, 2. So Stormy, if it helps you, you can always say H is the opposite of what you see. That way you don't have to think about it. So if you see a -1 in parentheses, you could say, oh, H is 1.
Okay.
So 1 in parentheses, you say, oh, H is -1. That way you don't have to do 2 steps. But I'm perfectly happy with either one. Okay?
Mm.
So our vertex is 1, 2. Okay? So what does that mean? Where is our vertex going to be plotted?
On 1.
1 to the right and how many up?
2 up.
2 up. All right. And -3 tells us what about the parabola when a is -3?
Then it's gonna open down.
Ah, right. It's going to open down. Okay. Phew. Okay. And check out the picture. I did it. They graphed their little axis of symmetry and put in our little random points at 1.5 and 1.25 and 2, -1. And they plotted their vertex and then crossed the axis of symmetry. I call it crossing the street because it's a dotted line. Cross the street straight across, and then you put your other point. And there's your graph. And you're right, Stormy, see, it opens down, and they have a point at vertex point at 1 to the right and 2 up. Perfect. There's only one last thing we have to do, and that's what happens if we're given a vertex. We're given a vertex, and they want us to make it in this form. I think it's pretty straightforward, but Miss Chris does too. Okay? So it's on the top of the next page, example 4, and there's a little paragraph. If the vertex and one of the points on the graph of a parabola are known, you can write the equation of the parabola in vertex form. All right, good. So here we go. Example 4. Write an equation given points. All right. Example 4. Write an equation for the parabola whose vertex is -1, 4 and passes through point 2, 1. So the vertex is -1 and 4, and the point is 2, 1. So we know a lot about the vertex. The vertex gives us h and k, okay? But its vertex form, if you remember, is x minus h squared plus k. Okay? They always take the opposite of the vertex axis of symmetry point. So here we go. The vertex of the parabola is -1, 4. So h is -1 and k is 4. So I want to stop for a second and point out something, because in the last example, notice that they gave the opposite h, the vertex, right? And in this example, they give us the exact vertex as h, and then when they plug it in, you get the opposite. So just be leery of that. Okay? You know, tread carefully and know that depending on what they're asking you, h is the opposite in vertex lands. Okay? So again, here they say h is -1 and k is -4. So since the point that it passes through is 2, 1, the graph of the parabola. So let x equal 2 and y equal 1. So we're going to use all this stuff to plug and figure out where we're at. Okay? So we're going to substitute these values in to the vertex form of the equation and solve for a. Because a isn't necessarily always going to be 1, is it? Here we go. Y equals a. So remember, the vertex form is this. Y equals a, open paren, x minus h, closed, squared, plus k. So when they plug all this stuff in, remember the point was 2, 1. So we put in 1 for y and 2 for x, and all those other things for h and k. Okay, so 1 equals a, open bracket, 2, because that was x, minus, and h, which is -1, so 2 minus -1, close it, squared, plus 4. Okay, so then you do all the factoring of that. 2 minus -1, 2 minus -1 is 3, right? 3 squared is 9. So that's why the next line says a times 9 plus 4. Right? So 9a plus 4 equals 1. We do some solving. We take, just like algebra, right? Who cares if it's an a or an x or a y or a w? Okay? You subtract 4 from both sides to get that 9a by itself. 1 minus 4 is -3. So if -3 equals 9a, to get the a all by itself, we do the inverse, and we say that divide everything by 9, and we get a equals -3 over 9, which is the same thing as -1/3 when reducing by our favorite fraction rule. So we actually have a fractional a. Who remembers what that does to our parabola?
Makes it bigger.
Makes it fat. That's right, Stormy. 1/3 makes it fat. Does it open up or down?
Makes it down.
Down. All right. So now that we know what a is, we can plug everything back into the original vertex form. Okay? So we have a, h, and k. So the equation of the parabola in vertex form is y equals a was -1/3, open paren, x minus -1, so they wrote x plus 1, closed, squared, plus 4. Because k was 4, h was -1, but remember we want the opposite of h. So again, -1/3, open paren, x plus 1, squared, plus 4. Whew.
No.
Okay? You can always check. All right. And we already talked about this, actually. Okay. How does that feel? Silence. Uh-oh.
Yeah.
Well, we're going to practice it, okay? Josiah did some already, so I'm going to give him more. Alright, go in vertex 1. If not, already in vertex 1, then, okay. Identify the vertex. You're right. So, for instance, try it on 6 and 7 to write it in vertex form, and then when they give you a point, where is it? Aha! 11 and 12 and 13. So try 6, 7, and 11 through 13, and Josiah, I'll give you a different set in a second. 6, 7, 11, 12, 13.